very manual setup. Now it's by default embracing incognito. Similarly with TLS, went from bespoke to default. And you can say the same thing for crypto, where basically you have private data, private state, private keys, whatever, and like all of these other pieces of cryptographic infrastructure, you expect the adoption curve to not go through centralized intermediaries that store your private data, but for you to have that private data locally. And so this is why we think private state management, key management, whatever, is not really the end game, and we're going to need client-side proofs because that's where the adoption curve of all the previous cryptographic infrastructure has ended up. And so what specifically can you do with these proofs? Anything you have a digital signature of, you can basically prove very easily in ZK proofs. And we've seen this a bunch. People have done things like passkeys, which let you send money with fingerprints, passports, which let you verify you're from a certain country and use selective disclosure. App attest lets you claim that an app executed correctly on your phone, and an Apple sign that yep, that was the correct binary executing. And of course, emails. And so where is the signature in emails? You guys mostly know this, but you do all emails have a signature on them, which is the RSA signature of the SHA-256 of the contents. You can prove that within ZK, and that's ZK email. This means you can get totally selective privacy. You can say, we're going to reveal only what we want to reveal. You have full provenance of the sender. So you prove, hey, this email was sent by Venmo.com, and there's a signature from Venmo.com. And so you're not trusting any third-party notaries, proxies, whatever. And the final thing is it's portable. You can verify all these proofs directly on chain. And so what are all the primitives that go into making this kind of proof? You need, of course, RSA and SHA-256. You also need partial SHA-256, where you can start it from the middle. You need substring extraction, where you want to extract very simple substrings. You want regex, where you have more complicated substring extraction. So for instance, when you want to extract the from email from an email header, it's actually fairly non-trivial to do with substrings. And to my understanding, regex is the only way to do this securely because it's just so complicated. You need quoted printable decoding to be able to decode email bodies. You want bit masking if you want to do things like whistleblowing. You need base64 decoding for attachments and for headers. And ideally, you want attachment parsing, but attachments are often very large and unwieldy. And so in practice, we're still working on making that faster. And if you want to hear about specifically the implementation of these primitives, how they compare in Noir to existing primitives, you should watch Jack and Ian's talk because they're going to be mostly discussing those things. But I'll focus more on the use case and the infrastructure side. So, the simplest version of what you might want to build with this is maybe like some whistleblowing. You can use a simple bit mask on top of the header and the body, and you can just reveal specific data you want to reveal. You can also build more complicated things, like, for instance, this domain marketplace. ZKP2P said if you have an email that says you transferred some domain on Namecheap from person A to person B, you can use that email on chain to unlock escrowed funds. So how does this actually look? You say, hey, I want this domain, sorosway.xyz. You send money to the smart contract to escrow for that domain. The domain seller sends you the domain. Both of you will get a Namecheap confirmation email. Either one of you can prove the email on chain to unlock the money to the seller. And so this is quite interesting because you can build arbitrary marketplaces or arbitrary systems on top of these proofs. But the kind of main barrier to this is people making new kinds of proofs quickly. For instance, if you want to support all domain registrars, you better now have an email for every single domain registrar. So the ability to both create new proofs and update those proofs should be very easy. And so we've thought a bunch about, okay, how do you generalize this kind of ZK-P2P technology? And the idea is there's a couple of key pieces of common infrastructure. One is an SDK, where you can imagine people who are maybe not super familiar with proof systems can use any ZK email proof automatically in an app. A registry where you can reuse existing proofs, and an archive where you can fetch old public keys. And so I'll kind of go over these one by one. So, okay, concretely, why do you want some sort of abstraction for people to use ZK email proofs over any type of proof system in their app? Well, the problem is, we are familiar with maybe some of these different proving systems, but an app developer who is trying to build a domain marketplace should not be expected to learn the difference between all of these. And so the idea is that if you can say, and we have investigated all of these and we've made MVPs in half of them, more than half of them, and we've written stuff about what people should build in and not build in. But this is not generally a skill set that people necessarily have. So how can you kind of get people to build these proofs without any knowledge of that? Well, you can imagine someone can just import, say, a value in their client-side app. They can say, look, I want to prove, say, the email for DevCon rejection. they just specify that and they say, I want to prove it either locally or not. If they want to prove it locally, you'll probably be doing a version of Noir or CIRCOM or something that is optimized to run in the browser and for client-side proving. And if local is false, like here, you might do a server-side proof, which maybe is running an SP1 or CIRCOM or something where you can hyper-parallelize it across GPUs. And then you can have everything be sort of intuitive as to what the steps are for your average app developer to use it. So you want to parse the email, you want to generate your proof, and you want to verify it on chain. And the app developer should not have to think about which proof system am I using, how is it happening, what is memory, these kind of like what is a witness, like these things should sort of be completely abstracted away. And so concretely though, how do you even get to this step? Like how do you define enough things related to say a DevCon rejection proof that the app developer doesn't have to think about it? And that comes in, that's where the registry comes in. The idea that you can have this database of easy ways to define proofs and then reuse them. So for instance, our whole thesis was it should be possible to define a new kind of email parsing pattern in 5 minutes. So the idea is you can specify what pattern you want to define, and you can then upload like an example email. And the idea is if you upload, say, an example email that you now want to make a proof of, we can parse out a bunch of information automatically from it. Concretely, we can parse out who the sender was, what the selector was, what the length of the header and body is automatically the second you upload that email. Then the user has to define how they're going to actually parse this email. So they want to say something like, look, I want to extract the username, I want to extract the talk title, I want to extract the amount of money they paid, I want to extract whether they got accepted or rejected. And the idea is you can just say, I want to extract those things from the EML, and we can just automatically send that to a Claude API or GPT-4 API or whatever and define this is what your regex should look like. And the reason we have this extra step in the middle and we don't ask users to define this is that we've noticed in practice, like we've had people generate like hundreds of these kinds of proofs, and it's like this part is like very tricky because you have to make sure that you're like comprehensive over all possible formats of the email. You have to make sure that you can't be spoofed. You have to make sure you're using deterministic regex syntax. It's like a very non-trivial task to define these kinds of regexes, and we've noticed in practice that sticking an AI on top of it actually makes sense and actually makes it faster to define this. And so once you've done that, then you'll kind of end up with a configuration that looks something like this JSON. You basically have something like these are the regexes I want to define. This is the sender, in this case devcon.org. This is how long the email is, and this basically parameterizes your entire proof. And the idea is once you compile this, we can now send this to a server, and we can compile the CIRCOM, the Noir, the SP1, whatever it is, proofs. And when you say I want to do it locally or on server, you can choose which language to use automatically. And so concretely, if you want to imagine, say, viewing all existing proofs, the second you've submitted one of these patterns, it'll appear on the registry page. You can see all the patterns that everybody else has used, what the smart contracts are. You can verify the trusted setup yourself, etc. And once you've kind of defined this pattern, we kind of auto-deploy an interface for you. We want this to be like as easy as like a Vercel kind of flow. The idea is we will automatically deploy a front end for you where you connect your Gmail account, where you upload an email, you select the correct email, and then the proof happens in the background. And so, concretely, once they sign in with Google, then we'll show, okay, these are all the possible emails that could verify for your pattern. So in this case, maybe they want to prove their GitHub username or something. We'll say, okay, these are all the emails in your inbox that would validly prove your GitHub username. And we can either auto choose one or we can let the user choose one. Subsequently, they click the email and they hit prove, and then they get the finished proof on a page, and they can share this automatically. They can share a link, so they can send this proof to anybody, and they can be like, yes, okay, this user, in this case, thing verified their GitHub automatically with this proof, and this ties it to either some ETH address or some action they want to take or whatever. And this makes it really easy to share these kinds of proofs. And you can say, I'm going to share the Noir proof, the CIRCOM proof, the SP1 proof, whatever you want, depending on the context of how you're sharing this. And you can do more, though, than just treat this as kind of like a Vercel auto-deployment thing. You can treat this also kind of like GitHub. Like the idea that you have repositories or patterns, and people can contribute, edit, fork, have versions, whatever. And this is quite interesting because emails update all the time. So, for instance, some emails like Venmo only updated once every 2 years. DevCon sends a different email for every event. And so you want the ability to say, look, like previously this is how we were parsing it, and now this is how we're parsing it. And people in their SDK don't need to think about it. It just automatically figures out what the latest kind of parsing should be. and we'll parse the email for you. And the idea is that, if you don't like this, you want to change it a little bit, you want to parse a different piece of information out, you can just hit fork, and now you can define your own pattern on top of that pattern. And so we're hoping this kind of creates like this very interesting ecosystem of proofs, because so far, I mean, people have done like dozens to hundreds of different kinds of ZK email proofs, and there's no kind of coherent ecosystem where someone can look and be like, okay, I want to use this proof, I want to edit this proof, I want to browse all the existing proofs. So we think this is going to be quite powerful. Okay, concretely, what have people built with this? Someone built, you can verify any document that you've signed from DocuSign/HelloSign. Someone proved you took an American Airlines flight and you either came from somewhere or went to somewhere, and they reveal those airports. This one proves you're part of like a Slack workspace. And so now you can kind of have an on-chain group that corresponds, that's only open to, say, people in your Slack workspace, which is kind of interesting. You can kind of now start to interoperate between these things in a very interesting way. You can say something like, oh, like, if you're part of the Slack workspace and you took this flight, then automatically reimburse you, or something like that. You can define these very interesting composable systems. Someone built something where you prove you exported your LinkedIn data, and then you sell it to an AI training company. Someone said you prove you exported your OpenAI chat data, and then sell that to like Anthropic. Someone proved that you automatically resolved some issue on GitHub. This is quite interesting for automatic disbursement of grants. I think someone is actually working on this for Noir, where I think like Aztec automatically gives grants if you close some issue, which is quite cool. And then you can also do fun stuff like John put up a proof where you prove you ordered a pad thai in Thailand. You can do this via a grab receipt and just parsing out the words pad thai and the location being somewhere in Thailand. You can do like very fun, silly things. And of course, you can prove that you got rejected from DevCon by proving you got a rejection. Okay, sweet. Okay, and so now you have all these proofs. Now the SDK makes a lot more sense. You just select any one of these, define if you want to be local or not, and the proof happens. And if people want to try this out, you can go to like a beta version of this at sdk.prove.email. This should really be like registry.prove.email, but I need the URL later. And see it, and we'll update this to have the new UI quite soon. But this should let you like kind of scroll through all the proofs. I think we have more than like 70, 80 at this point on the site. You can try defining your own. It's we have like tests and stuff to make sure it's being done correctly. Sweet. Now that I've gone over SDK, registry, another question is, how do you actually get these public? And this is quite important because regardless of whether you're using Noir, Circum, FP1, whatever, you always need to get old public keys. This is maybe not true for emails that were sent yesterday, because you can probably just hit DNS or the registry on chain and get that key automatically. But imagine you're going to take an email, you want to prove an email from 4 years ago. And now that email server has rotated that key out, you don't have access to those keys anymore. How do you do that? Well, you might imagine this is not a big problem, but this is a big problem. This is, for instance, Hillary Clinton's emails, or I think like her advisor or whatever that leaked, something like 8 years ago. And if you try to verify these emails today, more than half of them do not verify because those keys are no longer available. And this maybe doesn't matter as much in the Hillary Clinton case because probably the emails that verify are good enough. But when you have hundreds or thousands of people making proofs at scale, it better be the case that you can verify old emails. Okay, and so what is the actual logic that's happening here? The idea is that when you want to get the public key corresponding to some email domain server, you basically will go to their custom selector ._domain key that website, so maybe .venmo.com or .gmail.com or whatever. And this will let you get the DKIM key as it is today. But the problem is these rotate. So, in 6 months, this key might be gone. So, here the idea is we have this basically server that is archiving all of these, and it has over 1 million keys in it right now. And you can search any website, in this case, search venmo.com, and you can see all the keys that we know about that have been used since we started running this about a year ago. At this point, maybe like 9 months or something. And this is quite nice because this means one of the subtleties here with getting these public keys is this selector is actually unknown. Like, if I have the website venmo.com, like, you'll see the selector is like this massive random hash. And it's impossible for me to know what this hash is unless I've received an email from Venmo with a key corresponding to that hash. And so you kind of want a database saying, here's venmo.com and here are all the possible selectors, which is not possible to get otherwise. Okay, so now the big question is, how do you actually recover old public keys? Because that was the whole point of this exercise. And there's this kind of interesting quirk that you can do with RSA signatures, where if you have two old signatures, you can derive the old public key. This is like a little bit mathy, but you imagine when you have a signature, it's kind of you're taking the message to the exponent modulus, and you want to verify. You take that signature, like m to the d, and you take it to the power of some commonly known e, usually like 65537. But if you take two signatures and you express them in exactly this form, then you realize that uh, if you convert the modulus to being some multiple of the actual modulus, you can kind of say, look, when I want to verify the signature, I'm going to take this value to the power of e, and then I'm going to know that's the original message plus some multiple of the modulus. Now, if we want to get back the modulus, what we can do is we can subtract and take the GCD of these values. And so if we, do the calculation, and now we have, this remainder and that remainder, and we take the GCD, we are probably going to get n back, which lets us rederive old public keys from two old emails. Quite interesting. Right now, you have to trust that the archive is going to do this GCD process correctly, but my hope is that this whole system can be decentralized in the sense that you can have multiple archive nodes that all sorts of interested parties run, and when you want to, say, do this GCD, or when you want to upload emails, or when you want to upload public keys, all those archive servers are going to calculate and verify it automatically, and then now you have provenance from a bunch of different servers doing this archiving and archiving verification process. One way we got selectors is by people kind of uploading their email inbox, and we don't upload the entire inbox. The idea is you can take a script, you can run it client side, and you can calculate what the selectors corresponding to some domain should be, and then you contribute the selectors from your inbox into the archive. And there's public information anyways, but it's very hard to get unless you have existing email. So this is quite cool and a very easy way to contribute to ZK email. Sweet. And so I guess now that we've gone over the basics and the common infrastructure that all proofs running on all languages will need, I can kind of go into some interesting other applications that we'll probably spend most of the time discussing in other talks happening around the venues, but I'll give like a sneak peek of what they are now. They're not as relevant to Noir necessarily, but so one thing you can do is you can verify JWTs as well, like login, and I think Ole is going to give a talk on this later today, and Salil has also built a version of this in Noir. But the idea is you can basically sign in with Google and have that trigger any command on. And this is quite nice because this means that instead of having to get an email out of your inbox or having to reply to an email, you can just hit sign in, and that will generate a signature from Google to trigger some on-chain action. Another cool thing is this thing Salil built called Stealth Note that was also previously built by a Circom team called Nosy. And the idea is you can kind of have these anonymous confessions. You can prove that, say, you are an employee at Boeing because you prove you have an @boeing.com email address. And then you can say something like, confession, I forgot to put screws on the plane. The idea is that you can have more people reveal truths without fear of getting reprimanded by their employer or being doxxed or, being shot, like in the case of Boeing's. And, one of the problems here is that you really need good moderation here. Like if somebody tries to go on this sort of application and then spews hate speech, then the whole point of this is lost. And so one cool thing we do is that you can send the message before you post through a TEE for moderation, and hopefully, ideally, this will be ZKML, but we're not quite at the point where we can put Llama 405B into a snark. And that means that you can define your own kind of lens of moderation. You can say something like, oh, I'm going to browse this site, and I want to view everything except the hate speech. And you can say, this is going to be the prompt that it's going to get verified against the TE, and that's what I'm going to see in my feed. Or you can say something like, oh, I only want to see things related to companies in the Bay Area. And then now, you can verify, okay, like, is this related to that, yes or no, and it'll let you do this. And so this lets you kind of have your own view on the kinds of content you want to see. I think this is very important for moderation in anonymous forums. And the final thing is you can use either the JWT flow or the email reply flow to trigger transactions. You can kind of have an email-based smart contract that will enable things like receiving tokens directly to an email address, having emails directly approved on multisigs, logging in with emails and having that be session key based, and using your emails as wallet guardians. We have various talks talking about this, but because it's happening on the server side, it's not necessarily as relevant to Noir's client-side proofs, so I won't talk about it here. But I'll give you like the brief of what this looks like. You'll get an email looking something like, oh, you have received a Guardian acceptance request in the case of account recovery. If you reply to it, then it confirms you're the Guardian, you can recover the account, etc. And this flow is identical for all of these applications. You kind of receive an email, reply to it, and then trigger any one of these operations. And similarly to the generic SDK registry, etc., you can have this kind of generic Solidity library where you define, this is the kind of pattern I want to match in the email, and you can hit a Relayer API, any one of the decentralized Relayer APIs, and that can automatically handle getting that proof, proving it on-chain, and triggering the on-chain transaction. Sweet. And so if you want to learn more, you can go to our Twitter on the left, our main site in the middle, zk.email, and you can look at these slides on the right side. And I think we have maybe like a few minutes for questions.
Thank you, Yush. Let's give Yush a round of applause. We have time for one question.
One question. Right.
Let's go for one question. You have one. You raise now. If not, 3, 2, 1.
Sweet.
Okay. Thank you,
All right,
Aayush. That was an awesome talk. Following the spirit of CK emails, we then have Jack and Ian coming up to share more about their CK email application around doing CK reimbursements, as well as, well, their contributions to the CK email repo. Come up.